So this video is on finding the median from a grouped frequency table. Now we've talked about finding the mean and the standard deviation from a grouped frequency table. Remember, the median is the middle value in any data set, and so it would be at the point where half of the data is above it and half of the data is below it, and that's the median, and that's how the median is always defined. Now, the method for finding the median from a grouped frequency table is, I think it's sometimes called linear interpolation. If you ever see that term, this is, I think, what that is referring to. So let's take a look at a group frequency table. So there's our group frequency table. It's wages, and then the frequency refers to the number of workers who are paid that particular wage. So in order to find the median, we need to go, we need to see how many items of data there are. So if we add up all the frequencies, in this case, I already have this worked out, there's 100 workers there. So the sum of the frequencies, if you like, you can label that sigma F, or sometimes it's labeled N, to stand for the number of items of data in a data set. So we have 100 here, so that means there's an even number of items of data, which means there would really be two values in the middle. And if there's an even number, half it and add 1, and you'll get the two values in the middle, or the positions of the two values in the middle. So if you half 100, you get 50, add 1, 51. So it's the 50th and the 51st that are the two middle values here, and just count your way down the frequencies and see what group the 50th and the 51st are in, and that's the first thing we need to do here to get the median value, and that is to find the median group. So 10 plus 16 is 26, plus the 40 would bring us up to 66, so the 50th and the 51st values both lie in this group, and that group then is the median group. And that is the first thing to establish when you're finding the median from a group frequency table. If you write down the median group, then you will probably get a couple of marks in the exam just for doing that. So what we're saying here is the median group is the 300 to 375 group. Okay, sorry for my, I'm looking at this through my phone, so my writing's a bit all over the place. Once you find the median group, then you need to find how far into the median group you are in terms of frequencies, and then convert that to in the same proportion in terms of data. So because we want to go to the 50th and the 51st, and we can't calculate with two numbers like that, so in the calculation, go to the the 50th plus the 51st. In your calculation, it doesn't quite make sense in a common sense way, but mathematically go down and look at what would be at the 50.5 position. So we've already used up 26 items of data in the first two groups, and that means to land on the 50.5 position, we're going, 50.5 minus 26. So that would be, what is that? 24.5 into the median group. So we're 24.5 items into that group, and there's 40 in that group. So it's that proportion into the group, and we want to, that's the proportion in terms of the frequency. If we convert that proportion to in terms of the data, what we really want to do then is multiply by the group width, which is getting to the data, which is a group width of 75. And let's see what that is. Here's my calculator. So in terms of the data, we come that far into the group, 45.9375. So add that onto the lower group boundary, which in this case is 300. And that would give us that the median is 345.9375, at least approximately. That would be in pounds. It's close to the mean. If we did work out the mean on this in class, and as a very rough rule of thumb, the median and the mean are often close together. They don't always have to be. If you want to go back and check it out by working out the midpoints, I have the mean here of this as £338.25. So, but anyway, that's the median that we're looking at how to calculate in this video. Now, sometimes you'll see questions given as a grouped, it's still a grouped table, but it's given, the frequencies are given as cumulative frequencies rather than frequencies. So don't treat them like they're frequencies because they're not. Now, you don't always need to do this, but I'm going to do it here because it might be helpful. You can, without that much worry, you can recover the frequencies. If you think about how cumulative frequencies are found, the first frequency is always the same as the first cumulative frequency. And then if you take it away from the next figure, you will get the frequency of the next group down. In other words, in here would be 70 minus 38. So again, what is that? 32. 164 minus 70 then would go there. 178 minus 164 and 180 minus 178. So it's not that difficult to recover the original frequencies, and if you're used working like that, then you can do that. But in some ways the cumulative frequency is handy in that, for a start, the last one is the total frequency without having to add anything up. So sigma f here, or n for the size of the data set, is 180. So median is, well, 90th and 91st then would be the two middle positions with a data set of 180. Again, it's even, so half it and add 1 to get the two middle positions. In our calculations then, we would then be calculating with that value. So we want to come down into this data set to the 90.5 value. And again, the cumulative frequencies are helpful without, if you don't panic about them, because down to that group there, less than 60%, you've got 164 items of data, but the previous group was only down to 70. So the 90.5 value is in this group here. The median group would then be 40 up to 60. So again, if you write that down, you'll probably get a couple of marks for that part of the question. It's 40% up to 60% is the median group. And then we want to find out how far we are into that group in terms of frequencies. And again, we've used up 70 items of data so far, and we want to go up to the 90.5 value. So using up 70 means we come 20.5 into this group here, a median group. Now be careful because the frequency of that group is 94. So as a proportion of the frequency, it's that. To convert it to the same proportion data-wise, it would be multiplied by the group width, which is from 40 up to 60, so 20. And I will calculate that. So there we go, calculation is done on my calculator. I am getting 4.36 into the group data-wise. So add that to the lower boundary of the group, which is 40 here, to get the estimated median, which is 44.36, and then we're in percentages here. For comparison, the mean of that frequency table or cumulative frequency table, I think works out to be 40. And again, as a very rough rule of thumb, means and medians are often close together unless the data set is specifically contrived away from that. But they do tend to be close together. So there's working out the median from frequency tables and cumulative frequency tables. Peace out.